Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Betelgeuse's great dimming, why the star's 2019-2020 dimming shocked astronomers worldwide. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In October 2019, Betelgeuse, the brilliant red star marking the right shoulder of the constellation Orion and one of the 10 brightest stars in Earth's night sky, began to fade. By December 2019, it had dimmed to 40% of its normal brightness, fainting noticeably to the naked eye. By February 2020, it had reached its dimmest recorded state in over 150 years of photometric observations. Astronomers around the world pointed every telescope they had at the star. Social media generated headlines wondering whether Betelgeuse was about to go supernova, to explode in the most spectacular stellar death visible from Earth since the supernova of 1604, before the invention of the telescope. If Betelgeuse went supernova, it would briefly be visible in the daytime sky, would cast shadows at night, and would remain visible to the naked eye for months. Betelgeuse is a red supergiant star located approximately 700 light-years from Earth, with a radius approximately 900 times the Sun's radius, so large that if placed at the center of the solar system, it would engulf all 4 inner planets and extend past the orbit of Jupiter. It is a massive star in the late stages of its life, expected to explode as a type Roman II supernova sometime in the next 100,000 years. In stellar terms, this is imminent. The Great Dimming of 2019-2020 was the deepest dimming event ever recorded for Betelgeuse, and its timing, coinciding with a known period of the star's longer-term variability cycle, sent observers into overdrive. Was this it? Was Betelgeuse about to die? It wasn't, not yet. By March 2020, Betelgeuse had rebounded to its normal brightness, and subsequent analysis revealed the cause of the dimming. A massive ejection of stellar material from the star's surface had cooled to form a temporary dust cloud that briefly obscured the star's light. This surface mass ejection was of a scale never previously observed, 400 billion times more massive than a typical solar coronal mass ejection, and it created a dust cloud large enough to cover a quarter of the star's visible surface. The event was dramatic, but it was not a supernova precursor. Or was it? The most recent analysis of Betelgeuse's behavior since 2020 suggests the star may be accelerating toward its inevitable end, not in our lifetimes, but perhaps sooner than the 100,000-year estimate previously given. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we go further, if you are finding this investigation compelling, please take a moment right now to like this video, drop a comment below with your thoughts, and share it with someone who loves a good historical mystery. If you are watching on YouTube, hit subscribe and tap the bell icon so you never miss a new episode. If you found us through Facebook, tap follow on our page. It takes just a few seconds, and it genuinely helps us keep making these documentaries. Now, let us get back to the investigation. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from T. Predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding Betelgeuse's great dimming, why the star's 2019-2020 Dimming Shocked Astronomers Worldwide is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Betelgeuse, Alpha Orionis, is a red supergiant star approximately 700 light-years from Earth in the constellation Orion. It has a radius approximately 900 times the Sun's, varying between 700 and 1,000 solar radii due to its variability, a mass approximately 16-19 solar masses, and a luminosity approximately 100,000 times the Sun's. Betelgeuse shows multiple pulsation periodicities, including a short period of approximately 420 days and a longer period of approximately 9 years. It is expected to end its life as a type Roman II core collapse supernova sometime within the next 100,000 years, though some analyses have placed the remaining lifetime as short as a few thousand years. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the Great Dimming began in October 2019 and reached its minimum in February 2020, when the star's visual magnitude dropped from its normal V tilde 0.5 to V tilde 1.6, a factor of approximately 2.5 in brightness. This was the deepest dimming recorded in the 170-year photometric record of the star. The dimming occurred in two components: a coincidence of the minimum of the 420-day pulsation cycle and an unusual additional dimming that was not explained by the pulsation. The pulsation minimum alone would have produced a dimming of approximately 1.0 magnitude, the additional dimming of approximately 0.5 6 magnitudes was the anomalous element that triggered supernova speculation. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. The true explanation for the Great Dimming was established by a combination of Hubble Space Telescope observations, ground-based photometry, and infrared monitoring. Emily Levesque of the University of Washington and collaborators showed that the star's effective temperature dropped by approximately 140 degrees C during the dimming, inconsistent with simple obscuration by a cold dust cloud, but consistent with a cooling of the photosphere itself. Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics used Hubble ultraviolet spectroscopy to detect a massive outflow of material from the star's surface in September-October 2019, followed by the formation of a dust cloud. The full picture that emerged was a surface mass ejection unlike anything previously observed in stellar astronomy. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the 2023 follow-up analysis by Dupree and colleagues found that the surface mass ejection released a chunk of Betelgeuse's outer photosphere with a mass approximately 400 billion times greater than a typical solar coronal mass ejection. The ejected material moved outward at approximately 200,000 kilometers per hour, cooling as it expanded and condensing into solid dust particles at the appropriate distance from the star. The resulting dust cloud temporarily obscured approximately 25% of the star's southern hemisphere as seen from Earth, producing the observed dimming. This was a new class of stellar event, not a supernova eruption, not a conventional coronal mass ejection, but something in between. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of Betelgeuse's post-Great Dimming behavior has been anomalous. After recovering to normal brightness in March 2020, the star did not return to its expected pulsation patterns. Its 420-day pulsation period appears to have been disrupted by the mass ejection event, and the star has been in an unusual photometric state since 2020. A 2023 study found that Betelgeuse is now pulsating with a period of approximately 200 days rather than 420 days, suggesting that the mass ejection disrupted the star's convective envelope in a way that changed its acoustic oscillation properties. Whether this indicates an acceleration toward the supernova event or simply a temporary disruption of normal stellar mechanics is debated. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. If Betelgeuse were to go supernova, well, at its current distance of approximately 700 light-years, it would pose no danger to Earth. The nearest stars known to be at risk of producing dangerous amounts of radiation in a supernova are significantly closer, and even the nearest known candidate, Ik Pegasi, at approximately 150 light-years, is considered marginally safe. Betelgeuse's supernova would briefly reach a visual magnitude of approximately -12 to -14, comparable to a quarter to full moon in brightness, and would be visible in daylight for several weeks, then visible to the naked eye at night for 1-2 years. It would be the most spectacular astronomical event in human history if witnessed, though most current estimates place the date more than 1,000 years in the future. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Betelgeuse's great dimming. Why the star's 2019-2020 Dimming shocked astronomers worldwide. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the surface mass ejection theory is now the established explanation for the Great Dimming event itself. The surface mass ejection, a violent expulsion of a large section of the star's outer photosphere, produced a massive dust cloud that temporarily obscured the star's light. This explanation is supported by the Hubble ultraviolet observations of material outflow preceding the dimming, the infrared detection of the dust cloud during the dimming, and the spectroscopic evidence of cooling in the photosphere consistent with the loss of a surface layer. The surface mass ejection theory is not contested for the 2019-2020 event itself, but its relationship to the star's long-term evolution towards supernova is debated. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the pre-supernova activity theory, held by a minority of researchers, proposes that the unusual activity since 2020, the changed pulsation period, the surface mass ejection, and the general instability of the star's photosphere indicates that Betelgeuse is in the final stages of its evolution, and that the supernova is much closer than the 100,000-year estimate. Proponents argue that the specific type of activity observed is consistent with theoretical models of late-stage massive star evolution, and that the timescale could be centuries rather than millennia. Most mainstream stellar physicists consider this too speculative, but acknowledge that the late stages of stellar evolution are not well enough modeled to exclude a faster timeline. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the normal stellar variability theory holds that the Great Dimming was an unusually large, but fundamentally normal mass ejection event consistent with Betelgeuse's known status as a highly active, convective red supergiant. Red supergiants are known to have extremely turbulent photospheres with large convective cells and episodic mass loss, and mass ejection events of various scales are expected throughout their lives. Under this interpretation, the 2019-2020 event was merely the largest recorded example of a normal process, not a sign of imminent supernova. This is the position of most stellar astrophysicists who study red supergiants. What is striking about this debate is not merely that experts disagree, that is normal and healthy in science, What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Betelgeuse's Great Dimming. Why the star's 2019-2020 Dimming Shocked Astronomers Worldwide does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the Hubble Space Telescope ultraviolet observations taken in January and March 2020 by Andrea Dupree's team are the key evidence for the surface mass ejection mechanism. UV spectroscopy detected an unusually dense plasma moving outward from the star's southern hemisphere at approximately 200,000 km/h before the dimming reached its minimum. This outflow was detected specifically in the ultraviolet, where the chromosphere and lower atmosphere of the star are accessible, providing a direct probe of the mass ejection in progress. The temporal sequence, outflow detected before dust dimming, confirms causality. The material was ejected and then cooled to form the dust that caused the dimming. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented infrared observations by Andrea Dupree's team using the Stratospheric Observatory for Infrared Astronomy, SOFIA, and ground-based infrared telescopes detected a brightening of the star's southern hemisphere in the mid-infrared during the dimming in visual light. This infrared brightening is the thermal signature of warm dust, material that absorbs visible light and re-emits it at infrared wavelengths. The detection of the dust cloud in thermal infrared emission confirmed that the dimming was caused by dust obscuration rather than an intrinsic fading of the star's luminosity, distinguishing the surface mass ejection/dust explanation from the alternative hypothesis that the star itself was intrinsically cooling or contracting. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the disruption of Betelgeuse's 420-day pulsation period after the Great Dimming provides evidence that the mass ejection was a dynamically significant event that perturbed the star's interior structure. The 2023 analysis finding that the pulsation period has shortened to approximately 200 days indicates that the star's acoustic resonance properties have changed, possibly because the loss of material from the outer convective envelope altered the star's effective size and pressure structure. Such pulsation period changes have been predicted by stellar evolution models as a sign of interior structural change, though interpreting specific period changes in terms of evolutionary stage requires detailed modeling. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Betelgeuse's Great Dimming, why the star's 2019-2020 Dimming shocked astronomers worldwide. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Betelgeuse has returned to photometric behavior near its normal range since 2022, though the pulsation period disruption noted in 2023 indicates that the star has not fully returned to its pre-2019 state. Monitoring of Betelgeuse continues at high cadence by multiple professional and amateur observatories around the world, with particular attention to any recurrence of unusual activity. The ALMA radio interferometer has produced some of the highest resolution images ever obtained of a stellar surface, other than the Sun, revealing the convective structure of Betelgeuse's photosphere and the location of the region that produced the 2019 mass ejection. The Great Dimming of 2019-2020 has become a landmark event in stellar astrophysics, establishing a new class of stellar mass ejection more energetic than solar coronal mass ejections by a factor of 400 billion. The event prompted theoretical work on the role of surface mass ejections in red supergiant evolution and in the mass loss processes that precede core collapse. Understanding how much mass a star loses before going supernova is critical for predicting the properties of the supernova and its remnant. Betelgeuse is one of only a few nearby massive stars close enough to study in such detail, making it an irreplaceable laboratory for stellar evolution. When it does eventually explode, the existing monitoring infrastructure will capture the event in unprecedented detail, providing humanity with the most complete record of a supernova ever obtained. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Betelgeuse's Great Dimming, why the star's 2019-2020 dimming shocked astronomers worldwide. From the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Betelgeuse ultimately reveals is not just a historical puzzle, it is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please help us reach more people. If you are watching on YouTube, subscribe to the channel and hit the notification bell so you never miss a new documentary. If you are watching on Facebook, tap the follow button on our page to stay connected. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment telling us which case you want us to investigate next. The conversation continues. The investigation never ends.